Hello, everybody. Hello, and welcome to Physics Rich. Guys, today we are back with another episode on the amazing Soorya Veera problem. And this time we are doing the part 3, as I promised to you guys that I will be bringing the solution to this problem, in which we have Soorya and Veera once again in a similar situation where they are throwing apples on each other. Soorya is again throwing apple towards Veera, and he is on this side of the sphere. Okay, this is the physics rich sphere, and Soorya is sitting onto this side, Veera is sitting onto this side. Veera asks Soorya for the apple, which he's supposed to throw, and he's not supposed to throw in such a way that the apple gets dirty, but he's also supposed to throw in such a way that he utilizes the minimum speed to throw it. And our question is to find out that with what speed should Soorya throw the apple. And guys, let's discuss this beautiful problem. So we have the sphere, all right? You can assume it to be a sphere, you can assume it to be a cylinder. At best, it is a circle, okay? The cross section should be a circle. So we have Soorya sitting over here, we have Veera over here. We have assumed that the right side is going to be the x-axis and the vertical direction is the y-axis. And we figure out that Soorya throws the apple with a speed of Vs in this particular direction, and we're supposed to minimize the value of Vs. All right. Now, we have marked a few points. S stands for Soorya, V stands for Veera. The apple takes this yellow colored trajectory. It's a parabola, it's a projectile, hence it's an inverted parabola. And at this point, M, the apple goes tangentially to this circle. Also, as it passes through the highest point H, it goes onto this side and symmetrically traces a path which is similar onto this side towards this side. And then it goes over here and again tangentially passes this point N, which is tangent to the circle over here like this. And as it passes over here, it goes into the hands of Veera. Okay. Now, at the point M, we have assumed that it has a speed of Vm. All right. So, this distance Mn, this distance Mn, where what is N? N is the corresponding other tangential point. This distance Mn, we have to find the length of this distance. And you can understand that if I have assumed that the angle that the radius makes with the horizontal at this point is theta, okay, then the length which I am taking over here, this part, you can see this triangle. Can you see this triangle? If you can see this triangle, you'll realize that I am taking this length, only this length, okay? And this is the base of the triangle which I just showed you. That's going to be r cos theta, okay? If this is r, this is going to be r cos theta, all right? And because there are two of these, there is one over here and there is the other over here, all right? There are two of these. So you can see that the total length of Mn is actually 2r cos theta. Okay. Very importantly, this angle is going to be 90 minus theta, because you see the velocity Vm is tangential to this radius. This angle is 90 and I have assumed the angle between Mn and this radius to be theta. So this angle is going to be 90 minus theta. What is Vx? Students, Vx is the x component of Vm at this point. It's the horizontal velocity which does not change throughout the projectile. We are very well aware of this from the part 1 and part 2 of the Soorya Veera problem. Okay, we have discussed this in detail. Now, Vx is Vm cos 90 minus theta, because we will take the cos component of Vm over here. It will be cos of 90 minus theta, because this angle, as you can see, is 90 minus theta. We know that cos 90 minus theta is sine theta. So Vx becomes simply Vm sine theta. Also, as this apple goes from M to N, we understand that it will take a certain time to do that. Okay. that time will be this distance mn divided by this vx. So mn upon vx, which comes out as 2r cos theta upon vm sin theta, is simply t. Mn is 2r cos theta, which I have taken from here, and this Vx is Vm sin theta, which I have taken from here. Okay. So up until now, this part is clear. Moving on, there is one more important correlation, that as the particle, not the particle, the apple, well, it goes from m to n, it takes a certain time equals to 2r cos theta upon Vm sin theta, which we have already calculated. We can also calculate this same time from the vertical displacement. You see that as it goes from m to n, it's only along a horizontal line. There is no vertical displacement. The vertical displacement is hence 0. I have put y equals to uyt minus half ayt square. The acceleration along the y-axis is minus g, and the vertical component of Vm is Vmy. Now, if I put these values, I will get t equals to 2 Vm sine of 90 minus theta upon g. Why am I taking sine of 90 minus theta? Because Vm has a vertical component. Okay, this Vm has a vertical component. And if this angle is 90 minus theta, then the vertical component becomes sine of 90 minus theta times Vm. So this is my time period, which again is 2 Vm sine 90 minus theta upon g, and that will be equated with the time which we have found out on the previous slide. Now, if you solve this, then what do you get? Solving this gives us a very beautiful, very easy to understand relation. You can just do a little bit of math over here. If you want, you can pause the video and do a little bit of math over here. You will get Vm square equals to Rg upon sine theta, or simply Rg cosec theta. Okay. Now, this is the Vm which we are looking for. It's a very important relation. Now, you see, guys, we have already found out Vm in terms of theta. Now, all we need to do is to find Vs in terms of theta. If we can do that, then we can apply our minimization problem. So, how do we correlate Vs and Vm? We do that using the third equation of motion, which is V square equals to U square plus 2As. Now, you see, the final velocity and the initial velocity are taken in this motion, only from Soorya to the point M, from S to point M. So, the final velocity, Vm square, equals to Vs square minus 2g times this displacement, vertical displacement. What is the vertical displacement? It is r plus r sine theta. If you check this out very easily, you can find out that this distance is r, okay? This distance is r, all right? And this distance is r sine theta. So my total distance that I'm looking for is this, which is the same as this, and that is r plus r sine theta, okay? And that is r plus r sine theta, which is why I've put r plus r sine theta over here. And when you solve this, you get Vs square equals to Rg cosec theta plus 2Rg sine theta plus 2Rg. Now here, we can easily do the minimization of Vs because we only have Vs in terms of one variable. R and G are not variables. R and G are constants. R is the radius, G is, well, acceleration due to gravity. So this part is to be minimized. Simply this part is to be minimized. Now, how do you minimize that? Well, you can assume that, well, this part is a constant. This does not need to be minimized. Only this part needs to be minimized. So I have assumed a function of theta which appears to be a sum of two different terms, 1 upon sine theta and 2 sine theta. And if I do a little bit of calculus, if I differentiate it and I put it equal to 0, I will simply get sine square theta equals to 1 upon 2. Okay, all you have to do is to do a little bit of differentiation. I'm not going to be explaining the differentiation because I would like you guys to do this mathematics by yourself. Okay, just try this by yourself and you will surely get sine square theta equals to 1 upon 2 or sine theta equals to 1 upon root 2. You can reject the sine theta equals to minus 1 upon root 2 solution because we are not looking for negative angles. So theta simply comes out as 45 degrees or pi by 4 radians. Now you see, guys, alternatively, you can also apply the AMGM technique in this, because if you apply the AMGM technique, that means the AM must be greater than equal to GM. AM is the arithmetic mean, GM is the geometric mean. So if you find the arithmetic mean of this, you just simply get the sum of these two divided by 2, and the geometric mean will be the square root of the product of these two. So this thing simply comes out to be greater than 2 root 2. And also guys, this happens when both these things become equal to each other. When 1 upon sine theta and 2 sine theta become equal to each other, that is when this entire term gets minimized. Okay, any which way we will get that we will get that this, as this gets minimized, we will simply find out that this thing is just simply 2 root 2. Okay, this is simply 2 root 2. This whole part is just simply 2 root 2, which was supposed to be minimized. Now I have put the 2rg over here. From here, this 2rg comes and sits over here. Okay, and the minimized portion of this is 2 root 2, which comes and sits over here. So what do I get? I get the Vs square minimum value, which is 2rg 1 plus root 2. Now that is itself our answer. That's it. Problem solved. But how can I just simply leave you guys without telling you an even better way to solve this? Let me show you how it works. So my dear students, take a very quick look. What exactly are we solving? We are doing a minimization problem, aren't we? Right? We are doing a minimization problem. And minimization problem for what? When there is a certain range. When there is a certain range, we know that whenever there is a certain range, a horizontal range, the minimum velocity that is to be used to cover that range occurs at 45 degrees, which means that the apple must go tangentially to the circle and cover 45 at an angle of 45 degrees. So how does it work, guys? See, actually, we know that there is a tangential situation. The only way that the apple can cross is tangentially. We know that, right? And this tangential situation is symmetric. So I have drawn this other hypothetical path, the orange colored path, which is what I'm assuming that it could have been. This also could have been another possible path. But will the apple take this path for the minimum speed? We have to find that out. See, both the symmetric points are supposed to lie on a horizontal line. That is one thing that we are definitely sure of, because the apple crosses tangentially on both the sides. Okay, if it's tangential over here, it's also tangential over here. And these points are perfectly symmetric to each other, which means that they must lie on a horizontal line. Okay, but tangency is not the sufficient condition. It's a necessary but not a sufficient condition to solve this problem. To solve the minimization conundrum, to solve for the minimum speed, we must also look for the bisector condition. You guys remember in part 1 and part 2 that I told you, especially in part 2, that to cover the range, the given range at minimum speed, the particle must be thrown at the bisector of the angle between the incline and the vertical. Here there is no incline, here is just a horizontal. So the bisector happens at 45 degrees, which is what I told you earlier. Now the bisector, because it happens at 45 degrees, then this angle theta by 2, this becomes the bisector. Okay. So this theta by 2 must be equal to 45 degrees. All right. Well, the theta is completely 90. So here's what is happening. Here, this becomes the range. All right. This becomes the range. And this becomes the velocity of projection at m. And that's why theta by 2 must be 45 degrees. So the tangent occurs at 90 degrees. The tangent is 90. All right. And Vm should also point along the bisector of this angle. Okay, Vm should also be the bisector of this angle, and that's only possible if this theta by 2 is 45 degrees. And once you know that this is 45 degrees, then you simply get this length. You remember that this was 2r cos theta. So 2r cos theta simply becomes 2r cos 45, which is what I've written over here, and that is root 2r. And if you want to cover this root 2r with the minimum possible speed such that the sine 2 theta is 1, I have written the formula of range. You simply get Vm square equals to root 2 gr. And once you get Vm square equals to root 2 gr, you can just simply go back and apply this equation. We can simply apply this equation without the minimization. We can simply apply this equation, right? In fact, this one, yeah. So you just now have the value of Vs. You just have the value of Vm. Vm is what? Vm square is actually root 2 gr. You just put root 2 gr over here, and then when you solve for it, you will simply easily come to the final conclusion, and you will get the value of Vs. And that's it, guys. That's the best solution for this problem. And I hope you enjoyed this and I hope you learned something new. And I will see you next time with more such amazing problems. And until then, get physics rich.